So now you're going to put it all together. Please have patience because it's going to be a lot of steps going through these. But putting a lot of concepts together obviously takes time. So these are just basic directions for how to determine all of the things that I'm going to ask. First, you have to draw your Lewis structure. Then you're going to have to figure out how many steric areas you have. That will tell you what kind of electron geometry you have and your approximate bond angles. And then you can figure out the molecular shape. So that's what we're going to do for this next lesson, putting it all together. Now notice, oops, I'm going to erase that. So I've already put the number of valence electrons on there, and I'm going to go through the Lewis structures pretty quickly because I've linked in the formative. If you need more help with these, slower practice, you can check those out. So pH3 has 8 valence electrons. Phosphorus fully in the middle because it forms the most number of bonds. Now I've used 2, 4, 6 electrons. That leaves me with 2 to give me a total, once I put them on there, 8 electrons. So I check 2, 4, 6, 8. Yes, I use them all. This is the correct Lewis structure for that. Now notice how it's drawn. The way I have it drawn, it looks like the bond angle is 90 degrees. We know, have I given you anything that had a bond angle of 90 degrees? No. So this is not right. It's not 90 degrees. When I have up to 4 things, there is no such thing as a 90-degree bond angle. So let's figure out what the heck it is. First, steric area around phosphorus. So phosphorus is our central atom, right? It's the atom that's in the center. And attached to it, I have, we know lone pairs take up space, right? So that's going to be one area. That's going to be another area. That's going to be another area. And that's going to be another area. So I have a steric area or a steric number of 4. Now, what is my electron geometry? So if you have 4 things, the electron geometry counts absolutely everything. 4 is going to be tetrahedral. And the bond angle for that, you memorized, is about 109.5. Okay. And the shape. So now here's where it gets tricky. The shape of this, when we have hydrogen, 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 and that bond angle is 109.5, it's going to be trigonal pyramidal. So I actually usually like to redraw it like that, H, 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 something where they're not 90 degrees and that lone pair is up top and is just pushing that down. And I can easily see that it's trigonal pyramidal. And you can say trigonal pyramid. Oh, I don't care. Okay, so that's one way to do it. The other way to do it is maybe you're like, Michelle, I'm going to have a hard time memorizing these, so I'm going to use this beautiful little flow chart that you gave. You're not a flow chart, but a table. So steric things I had 4. I know the bond angle will always be 109.5, and the electron geometry will always be tetrahedral. I knew that I had a lone pair, so that makes it trigonal pyramidal. The other way you could do it is you could say, okay, I have a steric number of 4. So I have a steric number of 4. I have 109.5 as my bond angle. And because I had a lone pair, it's trigonal pyramidal. Whatever works best for your brain. Okay, so let's keep doing the next one. The next one is NO2. Notice, because I have a minus charge, I had to add an additional electron when I counted the valence electrons. So you should have 18 valence electrons. Nitrogen goes in the center because it forms more bonds. I've used 2, 4, 6, 8, 10, 12, 14, 16. I can't put any more on the outsides because they're full of their octet. So I have to put it on the nitrogen. And now I check for octets. I can see I have 8 here, yay. I have 8 around oxygen, yay. But nitrogen only has 6. So I'm going to take the electrons. It doesn't matter which side. I could take them this side or that side, but I'm going to take one pair and make it into a second bond. So I move it here. I make sure to erase it. Otherwise, I'd have the wrong number of electrons. And now you can see nitrogen has 2, 4, 6, 8. Yay, it's octet of electrons. Okay, so now what is the steric number? We're looking for how many steric areas are around nitrogen. I have the lone pair takes up space, this oxygen takes up space, and that oxygen takes up space. So my steric number is 3. if you have a steric number of 3, whoop. So if you have a steric number of 3, it's 120, trigonal planar, and I'm going to decide from there with the number of lone pairs. So I have 3 things. I always think 360 divided by 3 is 120. My bond angle is 120. This is flat as trigonal planar. So I always like to redraw it because I don't like memorizing. I was not given a little 3x5 card, so I couldn't memorize things. So I like to come up with ways so that I'm not likely to make mistakes. And what I would do, sorry, I forgot to put a little bracket and a minus on this guy. So what I like to do is draw it really with my 120 degrees. Do you see how this is about a third? This lone pair is taking up, this is a 120 and that's 120. So I can redraw it so it looks nice. Might as well put all those lone pairs. So it looks like this. And then you can see around it, you have those 3 areas. Now the molecular shape, you're going to hide. So I'm going to hide these. And then what is this shape? It's like a bent line, right? It's bent. So the molecular shape, you can use your table, or you can actually just visualize that this is a bent line. Okay, let's do the next one. So we have H2SiO. I know H is always going to be on the outside. S is in the middle because it forms more bonds. And oops, that's not what I meant to do. So I've used 6 electrons there, 8, 10, 12. I'm out of electrons. So now I need to check my octet. H is allowed to have 2. H is allowed to have 2. Oxygen has 8, yay. But Si only has 2, 4, 6 electrons. So I'm going to take these electrons from here and put them there. Okay, so I get here. And now I'm going to figure out the steric number. So the first thing I like to do is highlight the central atom that I'm looking at. I'm looking at Si. And I have this steric area is taking up space, this steric area is taking up space, and that steric area is taking up space. So my steric number is 3. My electron geometry is going to be trigonal planar. It is flat. When I have 3 things, it's like a little fidget spinner. Trigonal planar, bond angle is 120, and I don't have any lone pairs. Anytime you don't have lone pairs, you're like, yay, because the molecular geometry will be equal to the electron geometry. It's still just trigonal planar. I'm not hiding any lone pairs. Okay, so HCN, I have 10 electrons. H, C, N, I've used 4, 5, 6, 7, 8, 9, 10. I've used them all. Carbon only has 4 electrons. So I'm going to take this and move it here. And I'm also going to take that one and move it there. So instead of nitrogen hogging them, oops, it's going to share them. And if you're not sure, double check. 2, 4, 6, 8, 10 electrons. Okay, yes. Now, what is the steric area around this? Is called hydrogen cyanide. So what's the steric area around hydrogen on the carbon? Well, this is an area. That whole triple bond goes in the same direction. Even when we draw it, you can see it. That's an area. That's an area. So 2. The electron geometry, it's a line. It's linear. The bond angle, 180. And the molecular shape, I don't have any lone pairs. Linear. But linear will always just be linear. There's no surprise. So electron and molecular will both be linear. Okay. Okay. So it's a lot. If you need to, pause, take a little break, maybe even want to draw the Lewis structures on your own and then come back. Let's just meet in the next video because I need a minute.